Hi and welcome to part 2 of the solution of problem 414. In the last in the previous video, we just concluded that N1 and N2 are not independent. So we will have to do some calculation for these conditional probabilities. So let's just recall that for C, the probability that N1 is equal to 1, given that N2 is equal to 1, is equal to their joint probability, so the probability that N1 is equal to 1 and N2 is equal to 1, divided by the probability of what we condition on. So this is what we're going to have to calculate. And also, when we find the probability that N1 is equal to 1, given N2 is greater than equal to 1, we need to find their joint probability, which is the probability that N1 is equal to 1 and N2 is equal to 1, or N2 is equal to 2, right? Because N2 could be greater than equal 1, so that's either 1 or 2. So what I have here is actually the probability that N1 is equal to 1 and N2 can be either 1 or 2, divided by the probability of what we condition on, which is that N2 is greater than equal to 1, which means that N2 is either 1 or 2. And I can split this up into the probability that N1 is equal to 1 and N2 is equal to 1, plus the probability that N1 is equal to 1 and N2 is equal to 2, divided by the probability that N2 is equal to 1 plus the probability that N2 is equal to 2, because I just split up into disjoint cases. So this is the answer for C. And we can calculate that pretty easily. Here. We can calculate that pretty easily by looking at Excel once again. So what we need for this conditional probability here is we need to find the joint probability, which comes from the table, and we will divide with, I'm not really sure why this thing is here, and we will divide with the probability that N2 is equal to 1, which comes from the marginal probability. So that is 0.26. And then for the second conditional probability, you see that we have to add some stuff together. So we add So we add these two probabilities. So the probability that N1 is 1 and N2 is 1, it's this one, and then the probability that N1 is 1 and N2 is 2. And here below, we add the probability that N2 is equal to 1 and the probability that N2 is equal to 2. So it's a ratio of two sums. And that gives us 0.28. So that's the answer for C. Now moving on to the answer for D. What is the mean of N1 given that N2 is equal to 1? Well, we know the distribution of N1 given N2 equals 1, almost. So let's just see. The mean value of N1 given N2 is equal to 1 is equal to 1 multiplied by the probability that N1 is 1 given N2 is 1, plus 2 multiplied by the probability that N1 is 2 given that N2 is 1. Now we already know this value, right? Because we calculated it in C. So we just need to calculate this value. And we calculate it exactly the same way as we did in C, just with N1 equals 2 instead of N1 equals 1. So the reason why I do this here is because, well, I find the mean of N1 given N2 equals 1 the same way as I do for any other stochastic variable. I take the values that N1 can take and I multiply by the probability that N1 will take that value given that N2 is equal to 1. So the same case actually applies for the conditional expectation of N1 given that N2 is greater than equal to 1. Because what we have here is 1 multiplied by the probability that n1 will be equal to 1 given that n2 is greater than equal to 1. Then added with 2 multiplied by the probability that n1 will be equal to 2 given that n2 is greater than equal to 1. And as in the previous case, we have the probability from the first term from the earlier part of the exercise. So we need to find the probability that we use in the second term. So we just use the same methods as in C, and if you need to check, then this is the probability we have in the first conditional expectation, probability that n1 is equal to 2 given n2 is equal to 1, and this one is for the second conditional expectation, the second term down here. So all in all, if I need to find the mean of n1 given that n2 is equal to 1, then what this is confusing. That's just, sorry. So then what I do is I take the conditional probability of n being equal to 1 and multiply by 1, and the conditional probability of n being equal to 2 and 1 being equal to 2 and multiply by 2. That gives me 0.47. So if I know that n2 is greater than equal to 1 and not just equal to 1, then this conditional expectation kind of increases a little bit. So what I get here actually is the probability that n1 is 1 given n2 is greater than equal to 1, and the probability that n1 is 2 given that n2 is greater than equal to 1. So in the first term I multiply by 1, and in the second term I multiply by 2. So this exercise is very, very heavy on calculations, and you almost get a little dizzy on all of these calculations, but I guess we just need to carry on, and we will do that in the next video. So for this video we did C and D, and what we essentially did was we found the conditional distributions first for n1 given n2 is equal 1, and then for n1 given that n2 is greater than equal 1. And after we found the conditional distributions, we found the conditional expectations using the conditional distributions.